So I'm going to give you a presentation about machine learning, artificial intelligence that we use already for recognition of materials in streets and walkways. First of all, I'm going to give you a little introduction who we are, because there are two offices involved in this case. First of all, is FMT. We started 25 years ago as an architect, making files for telecom, for the deployment of the mobile network and the fiber networks. And with all kind of files that we need to make, technical drawings, visits, executions, drawings, health files, and so on. We need also to do inspections of infrastructure, pylons, buildings, measurements, and so on. So in 2016, we introduced drones to use for taking those measurements and the inspections. We made a company especially for executing and searching solutions for drones. We named it Indros. It's Innovative Drone Solutions. It's a company with enthusiastic pilots who search for solutions for our clients and cases that are not that obvious. We are not only collecting the needed data, that is very important, of course, but we make also a solution for the client to put that data into their software. It can be in lists via some kind of spreadsheet, Excel or something else, or drawings, and in all kind of CAD software. So our solution is not only the drone solutions, but also the solutions that our client needs for his further processes. The mission that I'm going to present is a mission that we already use almost every day. And it's about a client who asks us to make a calculation and make a definition of all the materials that are present in streets and in walkways. They ask that because they need to place their utility lines underneath the ground, such as water, gas, electricity, optical fiber, and others. So they need the length and of the trenches they need to make, of certainly of all the different materials, and because the cost of placing a kind of material back is sometimes very different to another. And they want that for a whole city in one time. So a very big area that we need to examine and and to look for is a very big challenge to manage. So first of all, what we do is we are trying to see what we get from the client to start with, because that's the first thing that we need. What do we have to reach? What do we have to manage? What kind of area do we have to fly? First of all, you see at the left an area. There are all dots. The lighter dots are something about 13,000, and the brown dots at above something about 12,000, I think. So that's every connection for every building, every house that needs to be connected to fiber, water, electricity, or something else. And that's one thing. So we know the amount of connections that we have to make. And at the other side, we see some lines, theoretically lines, that are presented, the lines of the gas pipes or the water pipes or the fiber optic. The problem is that they don't know what kind of ground they need to dig in. They don't know what they need to trench. So that's what we do. We are going to start with that area. We are going to make our preparations of the flights. We are going to make a planning for executing the flights. And afterwards, we are do the data calculation and the automatic analysis with the artificial intelligence and machine learning. So when we have our area to to search the materials, we are going to divide the area in different parts. So it will be easier to execute, because we are going to execute during some several days. And afterwards, each part we are going to define by street. So every street will be defined and every street will be programmed. So when we are on site, we can fly every street separately with our drones. After we have made that planning, we are going to have a meeting with the city or with the local police department, because we have the experience that the inhabitants of the cities are not that quite amused when we are flying with a drone like that above their houses, above the streets. So most of all, they call the police, and when the police isn't know what we are doing, it's much easier for us to do our work. After that, we are going to plan, and an average city is about something about 450, about 500 flights that we need to do, and we are collecting something about 35,000 photos for one city. After that, we are going to calculate the 3D models. First of all, we are going to calculate the first part, a small point cloud, where we can determine our ground control points that we have taken on site, because it's necessary that those orthophotos that we are going to calculate are geo-referenced. And we are going to place that photo into our CAD or CAD software of the client, so he can work with it. And it's already placed on the right place. We are trying to get the accuracy of something about 1 centimeter. So for our client, it's not that important, but for the recognition of the material, it's necessary that we have that detail of 1 centimeter. So here you saw the first point cloud and the checkpoints, the ground points that we have placed. And afterwards, we are going to calculate the right orthophotos. We are gathering something about 500 photos together, because otherwise our orthophoto will be too big to mention in our software. One orthophoto is something about 3.5 gigabyte big, so it's very huge files for working with. I'm trying to go to the next slide. So when we look at the orthophotos, they are placed on the right place. That's the first point that we are looking at. And of course, we are going to see if all the details in the photos are very visible. And as you can see, sometimes it's during a little bit longer, but you can see the differences of the materials. When we go closer in the view, we are going to see every stone and every point of the street that we need to recognize the materials on. So we have something about the GSD is something about 1.3 centimeters per pixel. So we have enough to get the calculation of the computer to examine the materials. Oh, this one. One of the first slides that I show you with all the connection points, that was one city. This is the result of all the orthophotos. As you see, we put them all together in our CAD software, and this is something about 80 orthophotos together from all the streets. And when we go and look at the details, as we did a little bit earlier, we're going to see that everything, every material, every line is visible. I have to say that one of the things that our client also needs is the place of the trees. The trees is very important in Belgium, because all the cities don't allow to make trenches underneath a tree. So every tree needs to be drilled. So certainly for the price of our client that he has to make the drillings or making the trenches, is very important that he knows how many trees and what is the distance that he needs to make a drilling underneath the ground. So that's very important cost for the contractor. If we see, in the meantime, you see the little drawing or the little photo of the orthophotos with the detailed information, where you can see all the little stones in the walkways, the way they are lying, the kind of materials. We are going to zoom a little bit closer now, where you can really see the right materials. And every material here in these are orthophotos, so we can measure every point and everything on it. To make a little difference between what we can reach in Google we can have a certain zoom, but you see that you cannot see any material, you cannot see any detail, you cannot see any stone in it. So we made the same photo in our orthophoto. It's the same place, the same spot, so you can see that we have a lot of more details in our orthophotos. After that, when the orthophotos are ready, you are going to use, because we have developed a software for, first of all, detecting the materials, and second, the theoretical lines where the pipes lines or the fiber optic or water pipes needs to be placed in the walkways. It's theoretically, but we are going to divide those according to the material underneath, and the material is read by the orthophotos. So here you can see he is going to zoom in to our orthophotos, going to check in a database to see if he finds something that matches the thing that he sees on the orthophoto. Here you see a visual view of something what normally is be done by the computer in another way. You don't see it like that. I just next. Okay. Yeah. When all those lines are divided and all the materials are recognized, the computer is going to divide all the lines, the theoretical lines, into the different parts of the materials. So here is also a visual way of showing it. He's going to draw some lines and divide the yellow ones into different pieces, and every piece of the line will be afterwards determined following the material that is underneath in the orthophoto. So you can see that the lines are going to change of color and line type. It's according the material that a certain color and line type is used. So afterwards, our client can see which kind of material is placed or is in the street. So here you see a whole orthophoto sample with all the streets and the lines who are divided in different parts and different colors, different line types. So there you can see all the different materials in the walkways. Of course, very easy after that, because we are working with CAD software, we can generate lists of those lines, and afterwards we can put them in some Excel, some other spreadsheet to make calculations and make a summary of the whole length of a certain material. For example, we have a concrete, we have some walkways, 15 kilometers of that kind of material. So next to that, our client can very easily see what kind of changes he needs to make and replace the material afterwards. Because we are going to fly with our drones, we have certainly everything in 3D. So we gave our client an extra. It's a 3D model, and the 3D model, we have already seen it in the former presentations, certainly from Pix4D, that those 3D, we can also import it in the CAD software, and we can measure also every building, every height of every building in the street, in the city, and make a whole 3D model of the city. We have seen more obvious models. This one is a little model that we have made because we have the first one we flew only for making orthophotos, and this one we have flown extra. We did some extra flights to see more details in the facades of the buildings, so we can certainly see how the buildings are conceptuated, and perhaps some facades are needed for the client to see which cables or which material the facades are, to see if it's possible to place cables against the facade. But that 3D model, we can also introduce it in our CAD software, and there we can give geo-referenced all the Z coordinates, and so we can see all the heights of the buildings. So every plot, every building in the city we can give, and can be an extra information needed for the contractors. We do this since the beginning of this year, and we do it for almost every day for about 10 clients now already. And it's a lot of information that is possible to use by different kind of people, different kind of companies who need that kind of information. So it's a very large and huge data set, and certainly the benefit that we can give is first of all, the accuracy of 1 centimeter, 1.3, and second of all, certainly the time that we need to do it. Average city is something about 1 month that we need maximum to give everything. So we scan everything, and we determine every material in the walkways and the streets. So I hope that now you can see that we already use it almost every day in our professional business, and it's getting better and better. And I think if there are any questions about it and to use this kind of stuff, you can always take contact with us, or by Drone Days, it will come to us certainly.